Everybody, this is Kiran here. Welcome to the project presentation of Big Data Analytics. My topic happens to be predictive analysis using Spark ML. As a as part of this project, uh, I intend to build a machine learning model to predict the fare amount for a NYC taxi trip by exploring a large data set of about 5.5 million trips. Spark MLlib will be predominantly used for feature engineering, model training, and evaluation. Tableau software, desktop software, will be used for visualization purposes. As said, Spark 2.3 will be predominantly used, including the MLlib package. Scala is the programming language, SBT is the build tool. Tableau would be used for visualization. I just have a desktop trial version. Also, Spark will be run on CentOS virtual machine, which in turn is running on macOS, having RAM of about 16 GB and a hard disk capacity of 120 GB. Data description. This data is available as a part of a challenge on kaggle.com. It has about 5+ million NYC taxi trips, but for this purposes of the project, a million record will be considered, and for Tableau visualization about 200,000 records will be considered. The file size happens to be about 1.2 gigs, and the format is CSV type, comma separated values. So the we have the following data. It gives you the fare amount, which is nothing but the cost per trip. It also gives you the pickup and drop off locations, geolocations. It also gives you the pickup timestamp, and finally the number of passengers during that trip, which is the passenger count. This is the overview of the steps to build a ML module. Step 1 would be to visualize and data cleansing. Second step is to select the features, the required features based on correlation, etc. Third one is an extra step where you can visualize the cleansed data uh, to see if it gives more meaning. Fourth step is the model selection, and finally you would evaluate the models and compare the results. Also in parallel I would be demoing. So I have my code here, and the Spark shell is already running here, so as and when I finish a step here I would demo the same. So let's visualize the pickup and drop off locations. So whatever that you are seeing here is the graph plotted by Tableau. If you see, the pickup and drop off locations are all over the place. This data set happens to be specific to New York City, in and around NYC, so this gives us an opportunity to cleanse the data. Now if you visualize the passenger count, there are records having 0 passenger count. I believe these are to be erroneous. Also, the New York City Taxi and Limousine Club mandates that only 4 passengers are to be allowed in a cab, and if it happens to be a bigger SUV, the limit is 5. So we will consider only such records whose passenger count lies between 1 and 5, while the others will be deleted. Now if you visualize fare amount, there are records with negative fare amounts. These will anyway be deleted, it doesn't mean anything. And again, a TLC indicates that that a minimum charge of for any trip happens to be $2.5. So that's like the base charge. So all the records, the records that we are going to consider should have at least a base charge of $2.5. Okay, let's go ahead and demo this particular step. These are my import statements. We'll see why we need that method in the next section. So that line item, that snippet of code should load the CSV file. Next step is to clean up the clean up the pickup and drop off longitudes and the latitudes. Next step is to clean up the passenger count. The final step here is to clean up the fare amount, wherein we need a minimum fare amount of $2.5. While that happens, let's go back to the presentation. So the second step here happens to be feature engineering and selection. So if you look at the pickup and drop off geolocations, it doesn't mean anything. I mean, it cannot be quantified, there is no weightage to it. So instead I will translate that into shortest distance between 2 points by using Haversine method. Ideally we should be calculating the travel distance, which is nothing but the blue line here, but I do not have access to a geo service in both offline or online mode. So instead I would be calculating the red line, the distance between the straight line distance between, or the shortest distance between A and B. So the next feature here is a timestamp. We are going to parse this timestamp into day of the week. Maybe a particular day would be busier, and that might give more information about the data. It would also be parsed into month and hour of the day. I would be using one hot encoder, estimator, and string indexer to convert these into their vector forms, or to vectorize the data. Finally, passenger count will also be considered as one of the predictors, because if you have more number of passengers, then maybe there is a delay in the trip, which eventually will impact the fare amount. Before we go to visualizing the cleansed data, let's go ahead with the second step, which is the feature engineering. This step would calculate the distance in kilometer by using the user defined function. It would also add new features, as like we discussed, wherein we are going to parse the pickup timestamp into day of week, month, number, etc. Okay, while that is running, let's go to the next slide. So now this is the cleansed data which I loaded back on Tableau. If you see, most of our pickup locations and drop off locations are clustered around the NYC, around New York City, which is how it should be. I also came up with these two graphs. The first one is just to see how busy a month is. In this case, looks like summer months are busier than others, while the quietest month happens to be August. It would be fun to figure out why August is the quietest month. The second graph gives you the busiest hour by the day. As usual, there are no surprises here. Fridays happens to be the busiest with the maximum number of trips. Trips increase from Thursday going into Friday. Maybe it's the TGIF effect. Thank God it's Friday effect. Model selection and evaluation. So this is still continuing. I'll just pause the video here. Okay, the first step is the second step, which is the feature engineering, is complete. We will drop the columns that are not required for building our model. So this is our final count. While that is getting processed, let's go back to the slide. Model selection and evaluation. At this point of time, right, we have our target, which is the fare amount. This is what we need to predict, and our predictors are passenger count, month number, day of the week, hour, and also distance in kilometer. I would be going by linear regression and calculate the RMSE and R squared values for the same, and we can compare that with the decision tree regression. Okay, so here is the count. It reduced from a million to, let's say, 9.4. So this is the snippet of code which will apply the R formula. Next one is where we are splitting the data set into training and testing data sets. This is the snippet of code which would apply the linear regression. This takes some time, so I would pause the presentation. Okay, that step is completed. So we would like to transform both the test and the train dataset, and eventually evaluate for RMSE and R square, root mean square error. Again, this will take some time, so I'm going to pause the video. Okay, for the linear regression, here are the values of RMSE and R square for test and train dataset. I would do the same for decision tree regression and see which one is better. Okay, so the decision tree regression is complete, and we can see that it is better, it's slightly better than the um, uh, linear regression model. So this has a better fit. Now coming back to the slide. So what are the learnings? Tableau turned out to be a great visualization tool. However, with large data set, it is excruciatingly slow. Kaggle data set is usually clean, but this data set had to go through few iterations to clean up the outliers and anomalies as much as possible. Also, there were a couple of instances where I had to make assumptions. For example, the distance. How do we improve this? We can try to correlate the weather data with the pickup timestamp to better our predictions, obtain the exact travel distance by hooking up to an actual geo service or a map service, maybe calculate the base and the minimum charges and the rest of the charges separately, maybe consider a big data set. So those are the future work or how we can improve the model. Thank you for listening. That's it.